All right, so first, we had a few assignments last week. Does anybody want to go over anything for that? Anything messed up? Yeah, Chuck.
I just have one delta math question on the
Sure.
monitoring.
Do you have the differential equation?
Yeah. 2IEX equals x minus 1 times 1 minus 9. Yeah.
Like that?
And y of 4 equals 2.
Okay, so if you separate the variables here, you get dy over 1 minus y equals x minus 1 dx. Right? Then integrate. So on the left side, what do you get?
I got negative ln absolute value of 1 minus y.
Yeah. And on the right side, what do you get?
X minus 1 squared over 2 plus c.
Okay, that's the problem. That's not right. The integral of x is x squared over 2, and the integral of 1 is x. Should be that. Right? You just integrate it like a polynomial.
Oh, yeah.
Right? You don't integrate it like it's something to the first power. You just integrate it like a polynomial. And then the rest you try to figure out, or you want me to go through it?
So it probably wouldn't work out like this, but I came down to like the absolute value of 1 minus y equals e to the something power.
Okay.
How would you solve for y in that case?
Okay, so first thing is you have a choice. You can either figure out what c is first or solve for y first. Which do you prefer?
I don't know. I think I solve for c first.
You solve for c first. So if you substitute in x equals 4 and y equals 2, you get negative ln absolute value of negative 1 equals 4 squared over 2 minus 4 plus c. So this is ln of 1, which is 0. So you have 0 equals 16 halves is 8 minus 4 plus c. So this is 4, so c equals negative 4. So now you have negative ln absolute value of 1 minus y equals x squared over 2 minus x minus 4. So if you divide by negative 1, you have ln absolute value of 1 minus y equals negative x squared over 2 plus x plus 4, right? Then e both sides, so absolute value of 1 minus y equals e to the negative x squared over 2 plus x plus 4. And then you're wondering, like, how do you get this out of the absolute value?
Yeah.
Good question. What do you guys think? Anybody else face this situation? Probably.
Yeah, I just never
You just kind of ignored it?
Yeah, I never use that.
That's what I would do, probably.
Okay.
So this would be 1 minus y equals e to the negative x squared over 2 plus x plus 4. So negative y equals e to the negative x squared over 2 plus x plus 4 minus 1. And then make everything negative. So you get y equals 1 minus e to the negative x squared over 2 plus x plus 1. We'll try that and see if it works out, hopefully. All right. All right. Anything else you want to go over? Those AP type questions were good? All right, so let me know if this doesn't work, okay, John? All right, so today we're just going to talk about other modeling situations with differential equations. More modeling.
I said it's wrong.
Oops. Why is that funny?
This is. Wait, do we have a math problem today?
You do, but I'm gonna wait to make sure we cover our normal stuff first.
Oh, yeah, you need paper.
Come on,
What, how am I doing that? You gotta have.
I got this.
Let me just double check everything here.
Cute. I like it.
Oh, look.
This is not the same. The answer is what I had to. No, it's not my bias.
Oh, okay.
Yes, I did.
You're the F-Zero.
What are you talking about?
Like, you know how you can get a different answer depending on if you
Well,
solve for C?
now you know, I wouldn't know. But
Yeah,
I
I
don't
don't think,
know.
like, I would do it
I mean,
myself.
you just,
Well, cause like, depending, it can change
just
too,
gotta
but,
have yourself.
cause C is arbitrary, it doesn't like not.
Never mind.
But it would tell me.
Never mind. Oh my gosh.
Well, this.
Let's
All
not.
right, here,
talk
no, no,
about it.
let's
just.
focus on the problem. So here's my thought process that I'm thinking right now. I'm thinking that on the right-hand side of this, at this point, before we got rid of the absolute value, I checked everything seems okay up to this point, okay? So at this point, you have an absolute value over here, which is always positive, and on this side, you have e to some power, which is always positive. So that's how it should be, correct? Okay, so the problem is if you just drop the absolute value, this is what I'm thinking. If you just drop the absolute value, then sometimes this isn't positive. And in particular, like if you substitute y equals 2n, it's not positive anymore. So there's no way that this could actually equal this if you substitute in y equals 2. You get what I'm saying? So what I'm thinking, and I don't know if this is right or not, but what I'm thinking is when you have the absolute value of something, 1 minus y, it's either equal to that stuff or it's equal to the negative of that stuff. You know what I mean? It's this if y is, well, if 1 minus y is greater than or equal to 0. So in other words, if y is less than or equal to 1, y is less than or equal to 1, it's that. And if y is greater than 1, it's that. So I'm thinking maybe we should have made it be y minus 1 at this point, since we're talking about a point in which y is greater than 1. That's kind of what I'm leaning towards here. Let's just see if that works. So this would be y minus 1 at this point instead of that. And then we would add 1 here, and this would be positive. And then that, so that would be the answer. So try that. See if that gives us the right answer. You know what I'm saying? Fingers crossed. That was right?
Yeah.
Okay, good. Does everybody understand the thought process there? So that's a little tricky. I'm trying to think of how to like generalize that so that when you're faced with the situation, you know what to do. Because if you think about it, like even like way back here, if I would have solved for y first before substituting in, before figuring out what c is, right? Because we always have that choice. You can always either find c or you can solve for y first. If I had tried to solve for y first here, like I wouldn't necessarily like put this together. So I'm not quite sure how to generalize that.
I think there were other ones where it was like the square root, but you know, it's like plus minus square root. Like some of them you had to do negative square root.
Yeah.
That's okay. So those ones to me it's a little more clear because for those, if the y value here, like if the function is y equals square root of stuff, whatever. And if this number right here is positive, then it's the positive of that. And if this number right here is negative, it has to be the negative of that in order to get the right answer. So for that, it's a little more like cut and dry for me. These ones are a little bit confusing for that. So I don't really know how to fix that for you, because that's not quite fixed for me. But I don't know, just being honest. So that's all I can really say about it. Now, another thing I will say about these problems in this section of Delta Math is they are much harder than any problems I've ever seen on an AP exam. So, I mean, that's a positive thing, that, yeah, we're having a little trouble with it, but you're not likely to see it on the AP exam. I know that's not super satisfying, but at the same time, it's a little satisfying. But, yeah. Sorry.
I think also being at the particular solution, 1 minus y, where y is equal to 2. Maybe you should realize that that's going to be negative.
Yeah.
So
yeah, that's what made me think of this. Yeah. Yeah. I don't know. You gotta kind of take it on a case-by-case basis. I guess it's not really. I'm sure it's possible to generalize it. I just haven't thought about it, and I don't want to tell you something that's wrong. Okay. Any questions about that? No. All right, let's move on. All right, so more modeling with differential equations. So the other day we were talking about the idea of proportionality, right? And we said a lot of times you have a situation in which the rate at which something is changing is proportional to the amount that's there, right? And so this corresponding to the differential equation, dy dt, the rate at which y is changing, is proportional to the amount of substance that's there. K times the quantity y, or whatever it happens to be. And this always yields an exponential function, y equals c times e to the kt. Okay, you solve this differential equation, this is the general solution you get every time. Any questions on how we get from there to here? Okay, so what I wanted to talk about today is sometimes you'll have proportionality like this in a little bit more complicated context. So for example, they might say something like this. What if they said like a bacteria has P cells. Are pieces of bacteria called cells? I wasn't sure about this. Does anybody know? Nobody knows biology in this room?
Maybe
Me neither.
it's a single-celled organism.
a single bacteria.
A single bacteria, is it called a cell? I don't even know.
Yeah, sure.
Sure, let's say it is for this purpose. Let's say, okay, so bacteria has P cells at time T.
Bacteria move.
Can bacteria move?
Yeah.
I can't move, but like us. That's why bacteria can crawl.
They're like little spiders, basically.
No, they're kind of just like pushing them around.
Right. So bacteria has P cells at time T and grows. In proportion to the square root of the amount present. So we could translate this into a differential equation too. Hopefully it wouldn't be too challenging. Like, what would the differential equation be? If this is all they said, and they said there's multiple choice, which of the following differential equations corresponds to this situation?
dp over dt equals square root of t.
Close. What's that?
Square root of t.
close.
Okay, so.
Yeah, it would be like a constant times radical p. So this would be the differential equation you would solve. And you wouldn't get an exponential equation if you solved this equation. Like if I solved this equation, this differential equation, I would, well, first separate the variables. Oops. So if I separate these variables, I get dp over radical p equals k dt. Integrate both sides. On the left side, I have p to the negative 1/2. So its integral would be p to the positive 1/2 times 2 equals kt plus c. Divide by 2. So p to the 1/2 equals, now, k is a constant, c is an arbitrary constant, so k is an actual number, and c is an arbitrary constant. So I would write this as k over 2t plus c, and then p would equal k over 2t plus c squared. So you get a very different equation. This is definitely not an exponential function, right? So I don't want you to overgeneralize this situation where there's proportionality involved, because sometimes it won't yield an exponential equation. That will only happen if the rate of change of the amount is proportional to the amount, okay? If it's proportional to something else, like the square root of the amount, or the square of the amount, or the amount minus 5, or whatever, it's not going to give you an exponential function of the same kind, okay? Let me give you a couple other examples where it's a little bit more complex, right? So what if you have something like this? What if you have an IV administers medication into the bloodstream at a rate of 3 cubic centimeters per hour. The body's organs remove the medication at a rate proportional to the amount of medication present. Set up a differential equation that models this situation. So I want a differential equation that models the rate of change of the amount of medication. What do you think? Let's let y be the amount of medication and t be time. dy dt. What do you think? Perfect, yeah. 3 minus k times y. So again, if you solve this differential equation, you're not going to get y equals c e to the kt. You're not going to get that. It's going to be something that looks different. Okay? But I just want to focus for now, instead of solving the differential equations, I'm hoping we can solve that. But instead of just focusing on solving them, I want to focus on translating English into this differential equation language. Does everybody understand? Does this make sense? Okay, this is the rate at which it's increasing. This is the rate at which it's decreasing. So the total rate of change is going to be the amount, the rate that it's increasing minus the rate that it's decreasing. Okay, let's see one other example. How about something like this? Each month, that says month. I meant to write month. Each month, balance of a loan B increases by 0.5% and decreases by $250. Same problem, right? dB dt as a differential equation. What would this one be, do you think?
Zero point zero zero five T minus 250
Not T,
or B.
B, yeah. Minus 250. This would be the differential equation that models that situation.
Wouldn't that be one?
Say it again?
But it's increasing.
It increases, so this is the rate at which it's growing. This is the rate at which it's decreasing, so that's why you're subtracting them. Does that make sense to everybody? Okay. So that's a skill you have to have, right? Reading words that describe a rate of change, and then writing that rate of change as a differential equation. And it usually be a separable differential equation that you can then solve. We can answer a question about this now. Like if they said, you know, if they gave us some parameters like at the beginning of the month there was $400, how much was there at the end of the month, or something like that. Like you'd be able to answer that question here, right? And same thing with like this situation. If they said, you know, gave you some actual information, some initial value information, you could find a particular solution to this differential equation. Okay. Another way that they change it up a little bit is sometimes they'll talk about two quantities being inversely proportional. So remember, if two quantities are directly proportional, it's like this relationship. If A and B are directly proportional, let me summarize. So if A and B are directly proportional, or simply proportional, that corresponds to the situation where B equals K times A, or vice versa, A equals K times B. That's what directly proportional means. Sometimes you'll see A and B are inversely proportional. And that corresponds to B equals K over A. Okay? Think about like inverse variation hyperbola, right? The inverse variation hyperbola is y equals 1 over x, right? This is the inverse variation hyperbola. One quantity is increasing, the x values, while the other quantity is decreasing, the y values, right? This is the inverse variation hyperbola. This is that situation. X and y vary inversely in this case. K just happens to be 1. Okay? So sometimes they'll say something like the velocity is inversely proportional to the square of the distance. S. So translated into a differential equation, you would say ds dt, that's the velocity, right? It's the change in distance, is inversely proportional to the square of the distance. How would we write that on the right-hand side? Not square root, square. S squared, yeah, this would be K over S squared. That would be the differential equation that corresponds to the situation. Does that make sense? So it's kind of like reading comprehension. You have to look at words and realize that they correspond to certain ideas and how to write them like equation-wise. Okay? Any questions on that? All right, the second part of what I wanted to talk about then is sometimes they'll ask you to determine whether or not a particular equation is a solution to a differential equation. Okay, so remember how to do that. To verify a solution is a particular solution to a differential equation. What are you supposed to do to it? No, you differentiate it, right? Because a differential equation is a derivative. If you get an equation and you want to verify that this is a solution to this differential equation, you take its derivative and make sure you get the same thing, right? So like, for example, they might say something like, so just differentiate and do algebra. For example, suppose I have something like is g of x equals x to the fifth minus 2x, a solution to dg dx equals 2x plus 5y over x. And they just want to know, is that equation a solution to this differential equation? So what you want to avoid is like taking the time to actually solve this differential equation, which, by the way, this differential equation is not solvable. Why am I saying that? Why can't we solve this? You can't separate the variables, yeah. And by the way, I should say dy. Yeah, you can't separate the variables, right? Like, think about how you would do that. It has to be a factor, like all the y terms have to be a factor of the right-hand side. And this 5y is not a factor of the right-hand side. We could like somehow like subtract something that would include a y and subtract something over here that would include a y, but that's not how separation of variables works. It's multiplying and dividing only is how you separate variables. Okay? So yeah, don't try and actually solve this to verify that that's a solution of it. Although that would be a way to do it, it's time consuming. It's a lot quicker to differentiate that and just make sure you get this. Okay? So differentiate g prime. This would be 5x to the fourth minus 2. Now, it kind of looks like that is not equal to this. But is it? I mean, we have to do a little bit of algebra. We have to take this and see if we can make it look like that. So if I just replace y with what we're saying y actually is, and then do some algebra, and maybe they are equal. So if I replace this y with that expression for g of x, I get 2x plus 5 times x to the fifth minus 2x over x. And my question is this equivalent to that? That's the question, right? Well, let's just do some algebra. This is 2x plus 5x squared minus 10x over x. If I simplify this, I get x to the fifth. I get 5x to the fourth But then if I take 2x minus 10x, I get negative 8x, divided by x would be minus 8. So this is definitely not equal to that. So the answer is no, it doesn't work. That is not a particular solution to this differential equation. Okay, because its derivative is not equal to this. All right, let's try another one. How about if they said, what if they said f of x equals 2 times ln x cubed, and they want to know if that's a solution to f prime of x equals 3f of x over x ln x. Solution to this question mark. So same process. I'm going to do some differentiation. First, I'm going to rewrite this f prime is going to be 6 times ln x squared times 1 over x, right? That's the derivative of that using the chain rule. And let's just see if this is equal to the same thing. I'm going to replace f of x with what we're saying it is. This would be 3 times 2 times ln x cubed over x times ln x. This is definitely going to work, right? Because look, this ln x cancels with one of those. I have 6 ln x squared over x, which is the same as this. So the answer here would be yes. Is the solution. Okay. Any questions on this? You want me to do another one? Or you feel okay about that? Okay, so 2 things you have to be able to do. Translate some sentence involving rate of change into a differential equation, particularly sentences that use the word proportional or inversely proportional. And then secondly, be able to verify if a solution, an equation is a particular solution to a differential equation, just by differentiating. Any questions about that? Okay. So let's just talk about the future here. So the test is now going to be on Tuesday of next week. I would get going on the progress checks. We have a couple more little topics to do that involve slope fields, which is a very strange looking but easy topic, in my opinion. And so we'll start that tomorrow and Friday. And then we'll go over the personal progress checks on Monday, and the test will be Tuesday on Unit 7. It's just going to be a 1-day test. This is a really short unit, so it's going to be a 1-day test. You will be able to use your calculator, although there'll be definitely some questions on there that the calculator is not helpful for. So you don't want to use your calculator for everything. Any questions about that? All right, so let's do the problem of the day. Now, how do I get rid of this again? I was trying to do it last period.
3 bars at the top.
This thing?
Yeah, stands for the sidebar on any website.
All right, thanks. All right, so let's try this problem. That's not working. Why is that working? Oh, there it goes.
We had one like this on our front one time, right?
Like this?
Yeah, kind of.
I don't know, did we?
Yeah, I'm pretty sure.
It wouldn't have been recently. There you go. When you feel like you have an answer, you can raise your hand. No calculator, this is a non-calculator question. Got an idea?
It's either C or D, I think it's C, but I mean, it could be, none of those values don't even matter.
Well, why do you think it's either C or D? How about that?
I just did that for each choice and.
Well, which one of these answers makes absolutely no sense? Right, okay, so A makes no sense, do you agree? Because if X was 3, then you wouldn't even have a rectangle, it would just be a line, right? So nobody should ever pick A, right? So then the question is, like, if you just pick a rectangle that's really close, you're gonna have a really narrow rectangle that doesn't have a large area, but if you pick a rectangle that's really wide, it doesn't have much height. So it's like somewhere in between is where it kind of makes the most sense, right? You think it's C? Okay, so when you see the word maximum, like when I see the word maximum, I always think first derivative test is what I'm going to try and do, right? So I'm going to try and find an expression for the area and then do the first derivative test on it. And that's all there is to this problem. This is just a maximize or an optimization problem, okay? So you're going to find the area of the rectangle, which is just the width times the height, right? That's the area of the rectangle, which is x minus 3 over x squared. So I'm going to just find out when this is at a maximum. A prime is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. If I simplify this, I get x squared minus 2x squared plus 6x over x to the fourth. This simplifies to be negative x squared plus 6x over x to the fourth. What's the next step in the first derivative test? What's that? Yeah, set equal to 0. Remember, a fraction is equal to 0 when the top is 0, so I can ignore the bottom completely. I'm going to factor it. Negative x times x minus 6. So x equals 0 or 6. 0 doesn't make any sense because it's like way over here, right? So it must be, the answer must be 6. The answer is 6. Now, why would this not be a complete full credit solution if this was a free response question? You got to do a little sign chart to verify that this is in fact a maximum, right? Because sometimes it might be a minimum, it might be neither, right? So you have to, they expect you to do a sign chart and to explain, if this is a free response, explain why it's a max. And if you do a little sign chart, it looks like this: 0, 6, it goes positive, negative, we're good. Yeah.
Awesome. So I would have given you 7 instead of 6 when you solve it out. How about the answer be E because none of the choices were the max?
They wouldn't have worded it this way, but yeah, it would say none of the above or something. It wouldn't say there's no answer though.
Yeah.
This homework assignment is, I think, in AP Classroom. I have to check, but it's on the Google Classroom.
Like the top left corner, where you put the comma down over x minus 3.